Hello, everyone. My name is Diana Marsala. I'm a software engineer at Meta. You may recognize me from last year, where I talked about purpose limitation at Meta, specifically the infrastructure we've built for this called policy zones. And today, I'm going to talk about what we actually tried before we got to what policy zones is today and why it didn't work. So first, I'll give a quick introduction to what purpose limitation is. Danny from Meta talked about this a little bit yesterday, but in case you didn't catch his talk. And then I'll go into some of the design points of what didn't work and just the lessons we learned through this process. So first of all, purpose limitation is this idea that data is or is not used for some set of purposes. This is a very common format for privacy requirements at Meta. And specifically last year, we talked about this toy example of banana data is not used for bread making purposes. Feel free to scan that QR code if you want to go look at our talk from last year and more about purpose limitation and our solution. But I will spare you the banana analogy this year and talk about some more concrete stuff. So for example, your religious view data is not used to personalize your experience on other Facebook products. If you are using a dating app, you may be interested in seeing matches that are of the similar religious views to you. And this makes total sense as a product experience, but as a user, you probably don't want this information about your religious preferences to be used for other things on Facebook. So this is one example requirement that we have at Meta that we uphold. So the initial design for policy zones took inspiration from security. Talking to other folks in the industry, this seems relatively standard. You look at the privacy problem, you say, hey, it looks very similar to security, let's do something similar. So for policy zones, we took a single policy and we propagated it across the stack dynamically. This contained a purpose taxonomy of allowed usages and disallowed usages. And ultimately, this would be propagated all the way down the stack until we finally hit a data store where we would perform a server-side check against the policy to ensure that whatever data you're loading, you are allowed to load and purpose limitation requirements are respected. To make this a bit more concrete, we can use that dating example from earlier. So if a user wants to filter their matches on Facebook dating by religious preferences, they will initiate a request from their device to Meta's servers. And then here we initialize that policy zone based on the relevant purpose. And then this gets propagated all the way through the stack to downstream services until it hits a storage service, and that's where we actually run that check. This strategy worked really well for us in the early days of policy zones. It enabled really quick onboarding. It matched a lot of security practices, but we experienced a lot of cracks starting to form as we tried to scale this system. The first of which was dynamic propagation. Customers of policy zones found this very theoretically simple, but challenging in practice to actually use. So this graph up here is just, we took an arbitrary asset at Meta and we graphed all of its upstreams and downstreams. So the green and the blue lines are pure upstreams and pure downstreams, while the pink ones are assets that are both upstreams and downstreams. So we have numerous services, data stores, product endpoints. There are often cycles, as this graph suggests. Services call back into themselves, or we have tables, say, that will have a downstream that actually ends up becoming their upstream and becomes this cycle. We also have asynchronous execution jobs that are kicked off from within product requests, and these may ultimately execute days later. So these are all interconnected in very interesting ways, and it becomes difficult sometimes to grok, hey, if I change a policy here, how will that actually impact the rest of our services? Another property that we experienced was that failures would occur very far from mistakes. So let's say that I have a dating web service that calls into an ads backend, just as a toy example. Ideally, you want that to fail the second you call the ads backend. You're like, hey, this isn't right. We shouldn't be doing this. But the initial design for policy zones would actually fail all the way downstream in the ads logger when you finally write to it. This could hop through multiple different customers' code, different teams, different services, different languages. By the time you get down there, you just don't have as much context as you'd like on the failure and how to fix it. You want to shift these failures left as much as possible, just like with anything else in software engineering. So the initial design we had was optimized for simplicity. It was very elegant, but ultimately we found it difficult to maintain. Our users would ask, hey, where did this policy come from? How do I safely change a policy? I want to reproduce this error, and we didn't really have good answers for them. So we introduced static policies at every service hop. This helped harden our code against upstream changes, and users were debugging at most one hop back. Failures occurred closer to mistakes, lots of nice properties. Users can, of course, still use dynamic propagation if they need to for multi-tenant services, for example. But we've in practice found that this is the vast minority of services, and this has dramatically improved the maintainability of our system. And this got us pretty far, but the next crack that we saw was these server-side checks that I'm talking about here. We built these checks inside very core infrastructure, very similar to security, because you want one choke point where you can run everything and you know that these requirements are being respected. But at this layer, sometimes all you have is the bytes. At best, maybe you have the type level information of, say, what data store this is, what use case ID. But we had a lot of privacy requirements that dealt with much higher level data. So for example, consent checks, very common thing in privacy. A user wants to consent to their data being used for extra purposes. Okay, how do you run that in a low-level service that has no understanding of the data? We also had requirement owners asking, hey, I want more debugging information. Can you give me a stack trace? Can you give me an app ID for this request? And by the time you get to these services, you don't have that information. Sure, you could propagate a stack trace over the wire, but good luck getting service owners to agree to that. It is very computationally expensive, balloons the size of your payload, so you just can't do that. In practice, what people want is they want access to a schema. They're like, give me a user ID, give me a product, I can store extra data on this about various different product level features that I can then use to build these higher level privacy features. So we had optimized for speed, essentially, of onboarding. It's really easy to onboard if you only have to write a check in one service. But we weren't able to build the kinds of privacy features that we wanted to build on this. So now we run policy zones checks client side. It's more work to cover all the clients, but we've developed a lot of solutions at Meta to make this much more efficient. And we found it's a far better debugging experience for our users. Don't need to propagate anything over the wire, so lots of efficiency wins. Our leadership really appreciated that. And all the privacy logic was able to be removed from these backend services. So a lot of these core infrastructure owners were also very happy because they had fewer dependencies. And the final thing I'm going to talk about today is the monolithic policy that we have. We got pretty far on this, but then we had a second really, really big use case. And they now needed to work in lockstep with all other use cases. So for example, if someone has an asset, they slap a policy on there, and then another privacy requirement comes along and they say, hey, that asset is also in scope for me. Now they have to get in a room with the previous requirement owner. They need to all talk about, hey, what is the actual list of purposes that should be on this data? They need to all agree on it, all align on it, align on the definitions. I don't know if anybody in this room has tried to define a purpose taxonomy. It's very difficult. Every privacy requirement has like their own slightly different definition. And so for the first mover, they had a lot of success on policy zones, but every user after ended up hitting these alignment bottlenecks. And so this was ultimately optimized for single use, and we found it wasn't very flexible as we needed to onboard new privacy requirements. People were saying, hey, I want to resolve these conflicts, or what if an asset already has a policy? And again, we just didn't really have answers to these questions. So what we did is we broke it all apart into multiple independent swim lanes. Of course, we still want to taxonomize things and unify these definitions, but this now moves it off the critical path so that engineering teams can still make progress on putting policies on things and making sure that they're doing all the checks everywhere without having to block on aligning with other teams. This also means if somebody changes their definition slightly of something, then somebody else doesn't have to worry about changing their definition just yet. They can maybe onboard to it later. And this helps amortize work. We've been able to amortize work where possible by identifying these common themes across requirements and getting them to align. But it's no longer on the critical path, which is really nice. And the other thing this enables us to do is that complex features like dynamic propagation that I talked about earlier only have to be enabled for the use case that actually needs it. So we can limit where we're introducing complexity only where necessary. Not everyone that's using policy zones has to deal with the same level of complexity as the most complex requirement. So just overall, some lessons learned. Prioritize debuggability over almost all else. We're running at a massive scale at Facebook, as a lot of companies are here. We're trying to run a big operational system that's not just privacy, but also many products and infrastructure services. And if you can't debug that system, It becomes very difficult to maintain. The other one is just consider client-side checks. Your leadership will appreciate the efficiency wins that it brings, and your system will be simpler. And finally, privacy requirements are ever-changing. They won't always agree. Don't force it. We've found a lot of success in really anchoring on this idea of flexibility and making sure that every privacy requirement we have is able to move as fast as they want without having to bottleneck on alignment. So here's the code again from my talk last year if you want to check it out. But I'm good to take questions now.